Okay, moving on to question 21. Any of the following can be true except, so could be true except means we're looking for something that must be false. All right, so we can check out these guys. Could be true that J runs first, could be true that M runs fourth. Could Nick run first? That we don't know. Could Nick and Peggy both run third? Yes. Could Owen and Peggy both run fourth? Yes. So the only one that we don't have an example of is C. Okay. Yeah, so I mean, really, this split that we did on the first question gave us really valuable information. And you're not necessarily going to know beforehand that this is the way to go, that this is valuable information to have. But yeah, if you do have it, if you did kind of, use it for one question, just know that any global must be true. You should be gleaning some things from that you can use in answering the other questions as well. And so having a bank of acceptable solutions, here we only have 2 acceptable solutions that we've created, and yet we've been able to answer most of the questions here, three of the questions, or I guess 4 out of 7 if we count question 18, just based off of these 2 scenarios. So yeah, super, super handy. Okay, 22. If Ruth and Peggy are assigned to the same team as each other. Now I know that I don't have a scenario where that's the case, right? Ruth and Peggy are assigned to different teams on both sides. So my first question when they say that 2 players are assigned to the same team should be, which team is it, right? Is it possible to determine which team they could both be assigned to? And so here I'm going to be looking for which of these 2 teams has enough empty spots that I could assign both R and P. So team Y has to include both M and N and either L or K. So 3 spots are already taken. We don't have room for 2 more. R and P will both have to be on team X. Okay, so X. Okay, we still have K or L there, and then we're just adding R and P, right? So we could have RP here or RP here. Those are our options for X, right? 2 options there. What else do we have going on? So on team Y, we're going to have, again, either L or K, and then we have to add M and N, and J and K have to be together. So, I mean, we could have J and K. So we could have J and K in X, or we could have J and K in Y. But wherever we have J and K, we're not going to have room for O. So J and K will be on a different team from O. So that's sort of interesting. Okay. So I think we're going to have to flesh these out a little bit more. Let's just come up with a couple scenarios. So here I'm going to pick K, put J down there, and then O would have to be in that 4th spot in Y. So if these 2 are connected to each other, we've got JK there, means we've got L here. M cannot be 3rd, right? We do know that. So N will be 3rd and M will be 1st. What must be true? Does J have to be 1st? No, we've created a scenario where that's not true. Does M have to be 4th? No. Does N have to be 3rd? Well, N is third in this scenario. We don't know if that has to be true, but we can't falsify that yet. So C is still an option. Does P have to be third? We do have P third here, but I can see that it would be possible for me to choose J and K here, and P could be fourth. So I can quickly falsify that. Does Ruth have to be first? I've falsified that here. So I didn't even need to create two scenarios for Y. I have two scenarios for X that are equally valid, and that helps me to eliminate D and E. So the correct answer here is C, also by process of elimination. And obviously this one took more time than the other questions because the work that we did on question 18 wasn't useful for this question.